edge AI-enabled EEG system for early detection of cognitive impairment and social neural synchronization. So here our basic idea is to go for development of a wearable unit that will be head mounted, as you can see in the video, and the signals information is being captured by this EE device is transmitted to a small form factor computing device where we will do certain number of processing and with using the signal processing unit. And as we know that since we are targeting a small device, form factor device, where we are doing this kind of processing, thus it is highly recommended to go with a TinyML model. Therefore, we have also developed a TinyML mechanism. So that is a real world analysis of the person, social neural synchronization and cognitive impairment. And this will provide us at a time glance or a real time, is there any chance that that person is about to go in the cognitive impairment. So therefore, we are naming this convention as early detection. So basically, if you come up with a framework, so we are integrating dry electrode acquisition with low processing because we are using a small form factor devices, and of course, a TinyML is used. So it definitely provides a low cost alternative, but the traditional systems are not suitable. And I can say that, let's say when we are in the in the cognitive impairment, then only we visit the hospital and get the remedy. So here our target is to move towards the real world and early detection. Therefore, we are coming with this approach, and the information that are being performed here on the TinyML model. This device is communicated via the LoRa communication, again preserving a significant amount of power. And if you talk about the methodology, so we are basically using the dry electrode wearable EEG capture multi-channel neural signals, and of course a low noise analog front end and on device analog to DC converter we will use. For pre-processing part, we are primarily using band pass filtering, artifact masking, and 1 to 2 second window sliding under low power constraints. And of course, we are using different biomarkers, example band power and Zoth parameter, RMS energy. And for TinyML, basically we are employing the quantization model, and we can we are not only quantizing the model post training, but also trying to go with an adaptive post training quantization where we are dealing with 4-bit, 8-bit combination, and that significantly reduces the resource requirement. So now a question arises, when we are significantly reducing the bit size, so what about the performance? So if you look into the result part, still we are able to achieve an accuracy of around 91.4% and 93. So because of this TinyML thing, we are not directly minimizing or curtailing the resources, but that is also aligning with the accuracy which we want. So if you talk about the data set, so we are primarily using two types of data set that we name 1 and 2, and they are the recent data set being explored in 2023.